Hi, in this video we are going to see about direct memory access. DMA. DMA controller is a hardware device that allows transfer of block of data directly between an external device and the main memory without continuous intervention by the processor. To understand the working of DMA controller, let us consider this diagram, which consists of a processor, main memory, system bus, which is used for the communication between processor and the other components, a disk, and printer, which is an output device, keyboard and input device. And the main part of this video, DMA controller, looks like this. It is a hardware device. So when we press a key in a keyboard, the signal will first send to the processor, give access to the main memory, and then the main memory will send the signal to the monitor. The monitor will show the output of the letter which we have pressed. Here we can see that in every work the processor is involved, which means if we press a key, the signal will send the signal to the processor and then to the main memory, which will take more amount of time. So if we remove the processor, we can get an advantage that we can save the time of accessing the main memory. So to do this work, we are introducing a concept of direct memory access. So now let us see about the role of DMA controller. So let us see the working of it. Here, if we press a key, the signal will directly send to the memory and then it gives access to the main memory. So there is a less amount of time used here compared to the previous method that we have discussed earlier. Here when we press a key in a keyboard, the signal will send to the DMA controller and the DMA controller will give access to the main memory, and then the main memory will process it and gives the output to the monitor, output signal to the monitor. So this is the working of DMA controller. Now we are going to see about bus arbitration. Bus arbitration refers to the process by which the current bus master accesses and then leaves the control of the bus and passes it to the another bus requesting processor unit. The controller that has access to a bus at an instance is known as a bus master. Here are the bus arbitration techniques. First one is daisy chaining method. Second one is rolling priority method. Third one is fixed priority method. Now let us discuss what is daisy chaining method. Daisy chaining method is a method which is the bus grand signal serially propagates through each master until it encounters the first one that is requesting access to the bus. So all the bus masters use the same line for making bus request. So here BRQ refers to the bus request, BGT refers to the bus grant. If the device 2 is requesting a bus request, it will send to the bus arbiter. the bus orbiter will be serially connected to all the devices and check the which device has sent the bus request, and it first serially check the device 1. So device 1 doesn't send the bus request, so it moves to the device 2. So it checks for device 2 is giving bus request or not. So device 2 is the one which sent a bus request. So the device 2 will be the bus master of this bus orbiter. So that is all about daisy chaining method. The advantages of daisy chaining methods are: it is very simple to construct. The user can add more devices anywhere along the chain up to the certain maximum value. And then the disadvantages are: the value of the priority assigned to a device depends on the position of the master bus. Propagation delay arises in the method. If one device fails, then the entire system will stop working.
Now we are going to see about rolling priority. The controller generates a sequence of master addresses. When the requesting master recognizes its address, it activates the busy line and begins to use the bus. The number of address lines required depends on the number of masters connecting in the system. There are n number of devices connected. Here BRQ is a request sent to a device and SAC is nothing but it is a selective acknowledgement. BGT which transposes the signal. This is a rotating priority bus arbitration. Advantages: this method does not favor any particular device and processor. The method is also quite simple. Disadvantages: adding bus masters is difficult as increases the number of address lines of the circuit. If one device fails, then the entire system will not stop working. And the next topic is fixed priority. In fixed priority, each master has a separate pair of bus request and bus grant lines, and each pair has a priority assigned to it. The controller selects the highest priority request and asserts the corresponding bus grant signal. In fixed priority bus arbitration method, from device, the request is sent to the bus orbiter. From bus orbiter, it transposes to the device 1. It happens repeatedly. This is called as fixed priority. All devices participate in the selection of the next bus master. The priority of the device will be determined by the generated ID. Each device on the bus is assigned a 4-bit identification number. The process does not depend on the central orbiter and hence the system has higher reliability. This is the interface circuit for device A. Here all the devices are connected to 5 lines. 4 lines is for ID transfer and 1 line is to start the arbitration. Let's see how it works. Assertion of start arbitration signal. The ID bits are placed on the lines. Arbitration lines are nothing but logical OR of all 4-bit device IDs placed on the arbitration lines. Say for example, if A is 0101 and B is 0110, when we are ORing it, we get 0111. That is the bits in arbitration line. Bits in the arbitration line is 0111. Now compare the pattern that appears on the arbitration lines to the device ID starting with MSB. If it detects a difference, it transmits zeros on the arbitration lines for that and all lower bit positions, else it checks the next bit. Here, device A has 0101. When we add 0111, we get a new pattern 0100. On device B, 0110, when we add 0100, we get 0110. Therefore, the B device becomes the bus master. Hope you like our video. Thank you for watching.